Welcome to classwork 7.6, textbook section 5.5, part 2. Today we're going to finish up our trig equations. So first, let's look at example 6. All of you highlight right here. That's important because that tells us that there is a restriction, so there's no need for a plus 2 pi k here. And the second thing you want to note is the technique we're going to talk about. The first one is right here. We're going to be using factoring. A lot of people, when they see an equation like this, they want to divide by tan because they see tan on both sides. You do not want to do this, okay? So I'm going to erase all that. You definitely want to avoid that step. If you do that, you're going to miss out on some answers. So instead, we want this equation to equal 0. Okay, so that's going to be our key right there. So let's manipulate this. We'll subtract 3 tan x. So tan x sine squared x minus 3 tan x, that should equal 0. Now we're going to use factoring. So tan x sine squared x minus 3, that should equal 0. Now we have two pieces we're going to work with. We have piece number 1 right here, piece number 2 right here. So we're going to write tan x equals 0, that's piece number 1. So let's solve that really quick. X should equal 0 or pi. And piece number 2, sine squared x minus 3 equals 0. So sine squared x must equal 3. Let's square root that. The absolute value of sine x must equal root 3. Therefore, sine x must be plus or minus root 3. But this is impossible. Root 3 is approximately 1.7, and we know that sine can't exceed 1, so this whole portion isn't really necessary. So 0 or pi is the only answer. Okay, that's example 6. Next example. So again, notice this, the restriction. So for all the ones in this particular homework, you're going to see that restriction, which is very handy. We're going to solve this using an identity, right? So if I highlight that, these headers are always big clues about what we're going to do. I want you guys to notice you have a cosine squared and a sine. You currently can't really solve it. So what we're going to do is change this cosine squared using an identity. Hopefully you recall that's the same thing as 1 minus sine squared. And we'll leave that sine x alone. There's not much you can do with that. Now I do that because now everything is in terms of sine, which is great. Let's multiply. 2 minus 2 sine squared x plus 3 sine x equals 0. Okay, let's rearrange this. So 0 should equal 2 sine squared x minus 3 sine x minus 2. I just like to make that first term positive. You don't have to do that. Now at this point you can do your u substitution if you want to, or you can just straight up factor it, but I'll do the u substitution. So that's 2u squared minus 3u minus 2. We're going to factor this thing. 2u and u, 2, 1, plus, minus. So u should equal negative 1/2 or 2. So that would mean sine of x, that should equal negative 1/2 or 2. And of course we know 2 is impossible, so we cross that out. So let's think, where does sine hit negative half? That's going to be 7 pi over 6, 11 pi over 6. Box it, good. Okay, 2 more examples. So just like last one, notice there is your 0 to 2 pi restriction. And again, we're looking for an identity. So hopefully remember cosine 2x, that's a big one. There are lots of identities for this thing. Cosine 2x, that would be cosine squared minus sine squared. That's 2 cosine squared x minus 1, or 1 minus 2 sine squared x. Now, knowing all three of these is good, but as long as you know this first one, you can always derive everything. But hopefully you know all three, and you just pick the one that we want to use. And the one we want is right here. We want that because notice how there already is a sine x in the equation. So by doing that, it'll save us some time. Let's grab that. We'll plug it in right there. 1 minus 2 sine squared x plus 3 sine x minus 2 equals 0. Okay, let's do some simplification here. So positive 2 sine squared x, if you imagine I just move it all to the other side, 0 should equal 2 sine x minus 3 sine x, and that would be a plus 1. And for those of you who are good at factoring, you can just straight up factor it. You don't need the u substitution if you feel comfortable. Just write 2 sine x, 1 and 1, minus minus. So sine of x should equal 1/2 or 1. So x should equal pi over 6, 5 pi over 6, or pi over 2. And there it is. Okay, now let's say you actually didn't remember this identity we use over here. Let's say you only remember this one. That's still okay. You plug that in right there. Cosine squared x minus sine squared x plus 3 sine x minus 2. And then, look at this. Cosine squared, that's just 1 minus sine squared x minus sine squared x. So notice how it still works out fine. We get to the next step. It just takes a little bit longer. Okay, last example. This one's an interesting one because at first glance, it looks like you really can't do anything. Again, we're going to highlight 0 to pi. It's always a good habit, even though they all have it for today. And then look at this, sine, cosine. That looks like something we know. That looks like the double angle. Sine of 2x, that's 2 sine x cosine x. So what we're going to do, let's multiply this whole equation by 2 to make it look like our double angle. So 2 sine x cosine x equals 1. Now use the identity in reverse. This is sine 2x equals 1. And now we can solve it. This is like what we did last time. We're going to draw 2 circles. Sine hits 1 at 2 places, here. So we're looking for 2 answers. We're going to grab this 2x. It is equal to those 2 answers we just found, which would be pi over 2. Add 2 pi. That's 5 pi over 2. And of course, remember that we are not done solving. We solve for 2x. So we're going to take this whole thing, multiply it by 1/2 to solve for x. So x should equal pi over 4 and 5 pi over 4. Final answer.